because I'm on the other side. But
so the next thing is that I need to set up my redirecting tool. For this, I need the VPN labels, which are actually shown by this command, which is the 1917. So where are my shells?
the VPN labels itself can also read via, if you are in the core, you can read them in Wireshark or your tool of choice for network sniffing, and see there the labels too. So you don't need access to an actual CLI from, for example, from a Cisco device to look at the labels. The labels are transmitted.
So, and if I don't type the labels wrong, which could happen, maybe didn't get much sleep this night, we should now, with both tool instances in place, be able to ping the system in the red VPN, but on the other side, in the green VPN too. So, which means...
And I'm still on the red customer side, so my port didn't change anything.
Yeah, he's still connected to this side, which means, okay, we showed you a ping from red to red is working. Ping from red to green, time's out. So after putting some, mixing up beer with spliff may end up in some kind of unresponsiveness. After you put some magic into this box, which are actually my two tool instances, we are able to ping from the red customer side into the green VPN. So, again, maybe you can stop the tools for a while, and you will see pinging from red to red works. Ping from red to green ends up in a timeout. There is no device connected to the green VPN side. So I will launch up the tools again. They're just in the data path manipulating the MPLS labels, and after that I can ping in the red VPN context, but I can ping the same device in the green VPN context too. So this means once I'm inside your MPLS core, I can move traffic from site A to site B, maybe pop up a new site C and get traffic out of that, and okay, just think about. I heard it's some kind of thing called applause after a demo worked. Thank you. So, what does this mean? Okay, I can, as an attacker inside your MPLS core, I can just spoof every system in your network I want. So I can just set up a fails routing entry, which says, okay, this square 32 network, this host, is now located in a new VPN, so maybe it's your DNS server, it's your central authorization portal, stuff like that. Maybe it's your LDAP, or just use your imagine. But we not only can relabel existing traffic, which means we had to be a valid customer, but we can also insert traffic. This is another tool. It's called MPLS TON. It again assumes that we are inside the traffic path and inside the core, and this tool just puts on a virtual tunnel interface and label every traffic that comes into this tunnel interface with a given MPLS label. And it also works bidirectional, which means, okay, every traffic arriving from the MPLS cloud labeled for this customer VPN is popped off the cable and thrown into the tunnel interface. So we are now able to put up a virtual interface on my local box, which is part of one given MPLS VPN. It's only tested with Linux so far, but the tunnel API should work on other systems too. So now an attacker has an MPLS VPN-enabled network stack, which means, okay, just sit one time in the cloud and insert traffic in every customer VPN you want. So, okay, we will have a demo for this too. Okay, so this is the tunnel tool. Where is my, this one, please, no, there it is. Okay, so I just launch up the tool, which now is configured for the other side. Okay. So I just launched up the tunnel interface in the mode, okay, you will be a layer 3 VPN, not a layer 2 VPN. You're working on this incoming and outgoing device. You're using these incoming and this outgoing MPLS label. And you also use this to incoming and outgoing MAC addresses. So after that, you will see I got a new interface on my notebook. Now, I will just apply some stuff to this interface. So I will assign an IP address. I take the MTU down because we have to add the MPLS label. And after that, I append some route to this interface. So now, from inside the MPLS core, got an interface connected to the green customer VPN, which his notebook is also connected to, and I'm now able to ping from inside the MPLS core the outside customer's VPN side. And you see, this is, I get response. This is actually bidirectional. I can do stuff like, okay, do an nmap inside this customer side. Maybe there is some interesting internal authentication system which I want to scan. And okay, we're running out of time. But you see, I can be part of a customer side just with creating a virtual tunnel interface. So what are your chances? What are your mitigating controls? First, okay, trust your carrier. If your carrier says, I got a trusted core, which, by the way, every carrier will say, then you're fine. On the other side, contractual controls might kick in. If you're bound to some contractual stuff, you can't just say, okay, I will trust my carrier. You have to ensure that all your traffic is secured. And this means, okay, you have to either authenticate everything. This traffic is really from that side, or you have to implement some special borders of trust, in this case, layer 3 devices that do some, let's say, IPsec over the MPLS cloud. That's the only chance.
The problem with the trusted core is also that until the PE devices and the P devices are all in the hand of the provider, and there is no way to connect to it, then